Hi class, welcome to Is451. I am Professor Fahmi Jelani. Today we're covering chapter 11 for voice and data delivery network. So let's begin. So as we know, there's several types of communication, data and voice. And today voice has been merged into data. We call it digitalization, and it's very common today. As you can see the example through your mobile app, especially it could be WhatsApp communication, Telegram, it could be Instagram, it could be Twitter. Right? As we commonly know, uh, via the telephone network, as shown in the diagram here, it's a local loop, and that's where most homes and businesses are connected. In the olden days, they have until today, they have the sensor office where switches are located, and most of the long distance call used to be routed by the operator. So in some countries, we have LATA, which is the local access transport area. These are basically the local stations that divide the network. Also, we have a trunk system where usually is high speed or digitalization. It's typically four wire system as compared to the normal two wire system. Trunk and the normal single wire is it's not the same. Where the normal telephone wire, we need an area code. Okay, so followed by the number you want to call. So installation of the telephone wire, there's a requirement of 12-inch. This is basically RJ11 requirement. So in the telephone system, as we know the process, when you make a call, there's a dial tone generated, and from there you press the number and we direct it to the switching office. And there's port services, plain old telephone services, landline. Also, it will be exchanged through PABX, or we know as PBX exchange. For offices, we have Centrex. So in initial the telephone system, in 1984, AT&T was broken up by the US government. This is prior their merger with another big company. Later we see the map. So because of its monopoly with modified final judgment, AT&T had to be broken up to several small companies. So today we have AT&T, which is Southwestern Bell, Bell South, and Ameritech, and Pacific Telcel. CenturyLink is the US West, and Verizon, Bell and Atlantic. So technically, you know the history of a company. This is illustration of the 23 companies. So after the breakup, we have LEX, which is a local exchange carrier, or the international exchange carrier. Certain terms that remains the same, like LATA, intra-LATA for local call. So we have class 5 and class 1 of the top office where users are connected. Okay. The Telecom Act in 1996, okay, is to increase competitiveness. Sorry. Okay. This is to open up local market. So now, as we know, cable companies are allowed to start up, and rather than being monopolized by the big players. Local company for LEX responsible to repair, right? 17 to 20%. So because that, so users are able to make their own preference for the telephone provider. Limitation of the phone line. There should be a 400 hertz, 4000 hertz requirement to prevent crosstalk. In order to go faster, there is a need for advanced modulation technique. Next, we take a look at the initial internet connectivity, which is the 56K modem. So here we have the diagram showing the primitive or legacy, we say ancient dial-up modem. So basically, it will convert analog to digital. There will be a dial tone like your telephone line. So in order to use the internet, you are unable to use the phone. Some resident or user, they will have 2 phone line. And in the event you have only 1 phone line, the internet will be disconnected if somebody try to call the house. Okay. So in dial-up service, we take a look what will usually happen. So when a user dials to use the internet, the modem or analog to digital conversion, they will have a dial tone and will dial up the local loop, which is a telephone network, and from there it will connect to the central office and will convert it to a digital signal. Let's take a look at some standard for the dial-up internet. We have the V90, V92, variable speed with 33 kilobits and 48 kilobits. Okay, next we have introduction of digital subscriber, DSL, which could provide a faster internet speed. Some of the specification in 100 seconds of kilobits, single digit. Distance is 5.5 kilometer or 2.2 to 3 miles, okay, from the office. Symmetric and asymmetric, upstream and downstream. Okay. So for DSL, there's requirement for multiplexer, where the connector are split to several lines. Let's take a look at the diagram. It much more clearer. Okay, here we have the splitter from the central office. Mentioned earlier, we have the asymmetric and symmetric. It comes in different form. They also have the light version, DSL2 and RADSL. Also, we have a cable modem. It's quite common. Now we still have consumers still using it. So the diagram it shows here, from the right, you can connect the TV and the computer to the modem, and from there it goes to the central office, to the internet. Basic architecture. Here we have the television, okay, more enhanced view, cable splitter, fiber nodes, and then to the office switcher to the internet. T1Ds, a higher speed, but this is more applicable for higher data transfer at 1.5 megabits, and you see them mostly in commercial user or business user. Some of the services, these are basically digital, and it's constantly transmitting. It requires 4 wire as compared to 2, and they transmit voice and data over PBX, and cost could be 350 to 400 per month, okay, which most company could afford. Let's take an example. Here we have 8,000 frames per second, constant transmitting. So from the formula, it could be derived at 193 bits, which is about 1.5 megabits per second. And then so with 7 bit of data and 1 bit control, the multiplication you get to 7 times 8,000, which is 56 kilobit. Let's take a look at T1 also. So the longer the line, the higher the cost for T1. Next we have frame relay. It's basically a lease line. Companies need to, or businesses need to rent a dedicated line. This are mostly practiced in countries where the internet reliability is not good. Next we have PVC, permanent virtual circuit, end-to-end. From city to city, for example. Move on, we have CIR, committed information rate. Because of the dedicated line, rates are guaranteed at nearly 100%. The example here we see companies 512 kilobit per second, bus rate 256 kilobit. So in order to stay below, bus up to 768 kilobits. As long as not last more than 2 seconds, then it's acceptable. As for asynchronous, went through this several times. Very high speed packet, both data and speed is 622 megabits for the virtual channels connection. Some scenario for company that requires high speed, they could consider a dedicated pipeline. So things to take note is ABR, availability bit rate, which is doesn't need to be transmitted immediately. Next we have the frame, 53 kilobyte ATM, the layout. Some of the advantages ATM, high speed, mentioned the disadvantages, high cost. Okay? The higher the speed, the higher the cost. This is basically typical for all types of network. Moving along, VPN, MPLS. They use frame delay. And VPN are mostly secure tunnel. We can see here the next diagram the comparison between DSL, cable, T1, frame delay, ATM, MPLS, and the speed and the cost, and basically the layout. QoS is basically quality of service. Let's take a look at conversion. Today we see there's a huge demand of data and voice. Companies merging together or buying each other. So companies that don't upkeep their technology will be out of the market soon. In terms of CTI or telephone, computer telephone integration, companies would have a call center, for example, to support the lines. Okay. This is basically help desk by clicking the network. Okay, let me see. Okay, CTI combines data and voice. Some app do include messaging, voice response, recognition, fax, and text to speed, things like that. Next we have also application like third party PBX, filtering. As for TTI, we have real time, real time. Some example, a company in Seattle, San Francisco, and Dallas, headquartered in Chicago. and they require a download speed of 400 kilobyte in 20 seconds. So the required transmission speed is 16 megabit. So what could be better communication? As we take a look, the choices and some of the solution we can have. 3T1 diagram, T Seattle, San Francisco, and Dallas, which are quite distant apart, and they should create a VPN. The next figure shows a 4-city network where they use frame relay, an alternative. Here it's connected to the cloud, relay cloud. Okay, in comparison, okay, we have T1, frame relay, ATM, okay, VPN. These are the costs that they need to consider. So, for example, we take Seattle to Chicago. The cost would be with distance and price totaling up of 6,325, and Dallas we have 3,500. San Francisco is 6,625. So in total, monthly cost will be 1,600. Some choices we need to take care. Okay, 3 port cost, 1 port Chicago, 3 port PVC, T1 cable, 4 of them, and monthly charge will be 4,495. For asynchronous, okay, totaling will be 1,943. And for VPN, MMBS for the 4 offices, monthly charge will be 2,900, but with initial fee of 4,000. So, as an IT person or management administrative, you need to consider all the different types of choices or availability of requirements and costs in order to make a clear decision for the system in your corporation. So that's pretty much it for chapter 11. If you have any question, doubts, please email me or drop by the office for an appointment. Stay safe and thank you. Bye.